Hey geometry students, 6th period. Sorry I couldn't be here today to go through these notes with you, but you get video notes instead. So if these notes end up going too fast for you, get what you can now, and then this video will be posted on Google Classroom that you can watch again and pause as you need to. But to start us off, go ahead and take your new note packet and turn to 4.1 notes, this page right here, where it says geometric evidence. So last week we did algebraic proofs. This week we're going to dig into some geometric proofs. And so this note sheet here is going to be our list of reasons that we can use, because we have statements and reasons in our proofs. These are going to be our reasons for geometric proofs. So we can still use things like addition property and division property and things like that. But this is going to add to that list. Okay, so here we go. The first one is definition of congruent. Now, we haven't talked a lot about congruent in this class, but the congruent symbol looks like this. It's like an equal sign, but with a little squiggle above it. And it's kind of like equality, but for things like angles and line segments and things like that. So the definition of congruent is that the measures of two congruent items are equal. So, for example, if you were starting a proof and you had that segment AB is congruent to segment DC, then your next step would probably be that AB equals DC, so that their lengths are the same. So that would just be your reason there for step 2 then would just be definition of congruent. Okay, the next thing we're going to talk about is midpoints. So a midpoint divides a segment, so a line segment, into two congruent segments. So if I have a line, A, B, C, those 3 points, if B is the midpoint, then I know that AB, that segment, is congruent to segment BC, because B is the midpoint. Okay. So the next one we have is a segment addition postulate, and we've already kind of experienced this in concept 1, where we have two smaller segments, and they add together to equal the whole segment. So that was a situation we saw, like if we had a line segment with a point in the middle, we can take the two smaller segments and add them up and set it equal to the whole segment. So we'd see something like AB plus BC equals AC. So we can say this because of the segment addition postulate. So if you see a line like that in a proof, that's because of the segment addition postulate. So just like segment addition, we also have angle addition. So where two smaller adjacent angles add to equal the whole angle. So that's where we'd see a picture like this with, let's see, P, Q, R, S. And so we could say angle PQR plus angle RQS equals the whole overall angle PQS. Okay, so we'd say angle PQR plus angle RQS equals angle PQS. Okay, so that would be the angle addition postulate. The next thing we've got is definition of angle bisector. So an angle bisector is kind of like a midpoint, where a midpoint divides a segment into two congruent segments. An angle bisector divides an angle into two congruent angles. So congruent means equal, remember? So just like same kind of picture here. if we had P, Q, R, and S. So it cuts it into two equal congruent angles. So these angles are both the same. So we'd see something like angle PQR is congruent to angle RQS. Okay, so that's an angle bisector. That's what it tells us. Okay. Next one, vertical angles are congruent. So we know that when two intersecting lines, they form opposite angles, and those angles are congruent. So it's congruent opposite angles, and those angles are called vertical angles. So the picture that we get is something like this. We could have, this is O, A, B, C, D. So here's a pair of vertical angles in that picture. So we'd get something like AOB is congruent to angle DOC because vertical angles are congruent to each other. So that's the reason that we would state if we saw that in a proof. Okay, the next one we've got definition of complementary angles. So complementary angles are two angles that add up to 90 degrees. So for that, we could have, if we had a picture like this where we knew that, let's see, A, R, H, S. Since these are complementary angles, we could say that angle ARH plus angle HRS equals 90. So we would say that because that's the definition of complementary angles. Okay, supplementary is similar to angles that add to get 180 degrees this time. So if we see a picture like this, and we know that these are supplementary angles, we could say angle A plus angle B equals 180. So that would be something we could say because of the definition of supplementary angles. Okay, so go ahead, turn the page now. On the back, we got two more definitions here. First one is definition of a linear pair. So a linear pair is just like supplementary, except those angles have to be adjacent. So we have two adjacent angles that add to get 180 degrees. Okay, so same kind of thing. Your angles are adjacent, and what we're going to be using that mostly for is to go angle A plus angle B equals 180. Okay, so the next thing is perpendicular. So that word means that two lines meet up at 90-degree angles. And then definition of a right angle, kind of the same thing, an angle that measures 90 degrees. So if I have a line, two lines like this, where that's a 90-degree angle, that is perpendicular. And that's just the definition of that angle happening there. So let's say this was angle B. We could say angle B is 90 degrees. Okay, so those are all of our new definitions and reasons that we can use. So go ahead, turn the page one more time, because we're going to go ahead and start the homework. But one problem on the homework is that when I converted this to a PDF, it took all of my congruent symbols and turned them into X boxes. So, wherever you see a black box with an X inside, turn that into a congruent symbol. So there's one there, one here, and one down here. There should only be 3 of them. Okay, so fix those into congruent symbols. And so here's the assignment. We're going to give the reason for each of the statements and draw a picture representing the situation. Okay, so for example, B is between A and C, so AB plus BC equals AC. So I'm going to flip back to my list of reasons here and figure out what that looks like. Okay, well to me that looks kind of like segment addition. Look, we've got AB plus BC equals AC. Okay, so I'm going to use segment addition postulate for my reason there. And then I'm going to draw a picture of what that would look like. So I've got a line with B in between A and C. So there we are. That's how we would do number 1. So go through this whole front page, there's only 9 problems, and give the statements, or sorry, the reason for each statement, and then draw a picture of what that situation would look like. All right, I'll see you guys tomorrow.